So this is putting all of our limits together with a calculator before we go over everything analytically by hand. So we're going to be using a calculator to look at these different ones to show you all the different limits that we have, not including as we approach infinity, of course. So the first one, we're going to be approaching 1, negative 1 that is, of this function, which is a polynomial. So let's plug it in our calculator, like that. And then we're going to use negative 1. So again, remember our graph, we want to look at it. If that's negative 1, a point to the left would be negative 2, and a point to the right would be 0. So we're going to plug in our min of negative 2 and our max of 0. So go to Window, a min of negative 2, max of 0, and then we hit Zoom Fit. That's our 0. So Zoom 0, and it gives us this. And we're going to start with our trace. So if we hit trace, it puts us right in the middle since we already did that. And that one is negative 7. The value exists. There's no reason to go, oh, well, what's it approach from the left? And what's it approach to the right? We're dealing with a polynomial. So at negative 1, it is negative 7. So our polynomial is negative 7. So we still want to do it from the left. So coming in from the left, we are approaching negative 7. Coming in from the right, we are approaching negative 7. See? Left and right, both negative 7. So if these two match, then we know our limit is negative 7. So that's what we're doing. We're going to do a left, a right, and if they're the same, that's our limit. So let's try another one. So let's plug it in. Remember alpha y, fraction, 3, and then parenthesis x minus 3 squared. So x minus 3 squared. Now this one is going at 3. So again, if we're going to be doing 3, a number to the left, it would be 2. A number to the right would be 4. So we want our x min to be at 2 and 4. X min at 2. X max at 4. And then we hit Zoom 0. And it goes up and up. So that's our graph right there. So it does this and this. So again, coming in from the left, that's positive infinity. Coming in from the right is also infinity. And since they are both infinity, our limit would be infinity. Let's try it again now. So far we have a number. We have infinity. And now this one's probably going to give us some issues, right? Let's try it again. So back into y. So alpha y, number 1, and we get x squared minus 1 over x minus 1. This is my favorite. And now this one's at 1. So again, a number to the left would be 0. A number to the right would be 2 to give us a 1 in the center. So our x min again is 0. And our x max is 2. We hit Zoom 0 to fit it. There's our graph, and hopefully it'll show it. Yep, see our nice little hole there, but we don't care if there's an undefined value. So our line, whole line, what we're looking at is what we are approaching. So coming in from the right, from the left, and from the right, what are we approaching? So let's start with the left. If we hit trace, and scroll just a little bit to the left, we get 1.98. And you scroll to the right, you get 2.01. So you already know it's 2. Coming in from the left, it's 2. Coming in from the right, it's 2. So this value would be 2. So we're coming in at 2. And from the right, it's 2. And so since they're both 2, the limit is 2. And I'm going to show you how to do this analytically in a future video. But right now we're just doing this by practice. All right, we need to have a limit that doesn't exist. So that means they're not going to approach the same number. So if we're at 4, left would be 3, right would be 5. And so this means it's not going to approach the same value. So let's plug it in and see what we get. So alpha y, number 1, x plus 3 over x minus 4. Change our window to 3 and 5. So 1 to the left, 1 to the right. Hit Zoom Fit. And this one goes to negative infinity, and that one goes to positive infinity. So it's down and it's up. So coming in from the left, we get negative infinity. Coming in from the right, we get positive infinity. So together that would be d in E does not exist. And so these are the situations that we're going to be running into when we start the limits analytically. But you can always use your graphing calculator to verify your answers after you work them out by hand. All right, thank you.